Hi everyone, and welcome to practice problem learning objective 1-2 problem number 1. In the previous videos we looked at parts A and B. In this in this video we are going to look at the solution to part C, which is asking us to calculate depreciation for this company's asset using the sum of years digits method. Now, this sum of years digits method is an accelerated depreciation method, and it's an accelerated depreciation method in the sense that its goal is to record more depreciation expense early on in an asset's useful life and less later on. So the goal is to accelerate the recognition of depreciation expense so that more is recognized early in the useful life of the asset. And the assumption is in reality, more of the asset's value is used up early in its life than later. All right, so if we were to, for example, let's say we were to graph out, right, let's say that we have a graph here. The x-axis is, let's say this is time, and let's say this is the asset's value. And what this is saying, what this accelerated method is saying or assuming, is that let's grab a different color here. The straight line method basically says that the asset's value goes down like this. You know, it's a straight line. What accelerated methods are saying instead is that the asset's value goes down more quickly early on and then less quickly later on. So let's undo that. Let's say I want to draw this so it's not connected, right? That's basically the idea. So let's say green is accelerated methods, and black represents straight line depreciation. Right, you get to the same answer at the end, but the green line is saying this asset plummets more quickly early on than it does later on. All right, so that's the idea here. With both double declining balance, sum of years digits, and other accelerated depreciation methods. Now, I have to say up front that the sum of years digits method is almost never used. It's almost never used in practice. And so as a profession, as a field of study, I have no idea why we still teach this method. And it's still tested on the CPA exam, which is the only reason I am going over it here. It's a methodology that you would need to know on the CPA exam, and specifically the financial section of the CPA exam. So I feel it's important for that reason and that reason only. So what does this thing look like? Well, what it says is the sum of years digit method says that you can take the useful life of the asset, right? And plug it into this. This is the, let me zoom in here. This is the sum of years digits formula. And we're going to say the variable n represents the useful life. All right, so we're going to say the formula is n times n plus 1 divided by 2. So this will be our formula for sum of years digits. This will give us our depreciation amount. So in this case, we have an asset that has a useful life of 10 years. So we're going to say 10 multiplied by 10 plus 1 divided by 2. And so what you get is 10 times 11, right? 10 times 11. 10 times 11, right? 10 times 11, which is what? 110, right? And you're going to divide that by 2. And so the sum of years digit formula gives you a number 55. All right. So we're going to use that number to calculate our depreciation expense. And you might say, how? Well, you're going to say in 2024, right? 2024, you had an asset that had a cost of $42,000, right? And unlike the double declining balance method, we are going to consider the residual value of $6,000. So we're going to say 42,000 minus 6,000. We're going to multiply that by what? Well, in the in the sum of years digits method, we're going to say what was the remaining life of the asset as of 2024? It was 10 years. And we're going to scale that by the number we just calculated, which was 55, right? Which will give us, if you do 10 divided by 55, that's about 18%. And we're going to multiply that by 42,000 minus 6,000, which is 36,000. We're going to get 6,545.45. Okay. And if you remember, they say that this asset was purchased on April 1st. Therefore, we need to adjust for the portion of the year that we own this asset. So we are going to multiply this by 9 over 12 months. 9 over 12 months. And this will give us $4,909.09. $4,909.09. Okay.